Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this video lecture. Today we will discuss about six-member ring containing oxygen as a heteroatom. Oxygen as a heteroatom. Six-member heterocyclic compound containing oxygen are well known and many of them occur naturally. Many of them occur naturally. The heterocyclic compound containing one oxygen atom can be studied under the following three important headings. One heading is Pyran. Today's our heterocyclic compound pyran. One is pyran. Second important six member ring heterocyclic compound is beryllium salt. And number 3 is pyrons. These are three very important. The heterocyclic compound containing one oxygen as heteroatom can be studied under following these three: pyran, beryllium salt, and pyrons. We here discuss only their structures and then we continue in pyrans. According to our syllabus, these two compound is not studied here. Beryllium salt and pyrons. We studying only pyran. So first of all, we see the structure of these three group. Pyran, six-member ring heterocyclic compound containing one oxygen as heteroatom. This is pyrans. Beryllium salt containing one heteroatom as oxygen, and this is connected with salty material. This is beryllium salt. And one more, third compound, pyrons, that are oxygen as heterocyclic compound, and these both are pyrons. According to our syllabus, we have only six-member ring, oxygen as a heterocyclic atom is pyron. So I rub out remaining two and we concentrate in pyrons. Pyrons are the simplest and parent compound of all six-member heterocycline having oxygen atom. I further repeat, pyrons are the simplest and parent compounds of all six-member heterocycline having oxygen atom. Pyran exists in the following two tautomeric form. We have two tautomeric form of pyran. First of all, we see the tautomeric form of pyran. If we give numbering, then 1, 2, 3, 4, 5, 6. This is alpha pyron. And this is gamma pyron. If we write down alpha pyron as 2H or 6H, 2H or 6H pyron, and this is 4H pyron. So these are the two tautomeric forms of pyron. These are very important tautomeric form of pyron. Pyrons have not themselves been prepared. Pyrons have not themselves been prepared, but their simple derivatives have been synthesized. Their simple derivatives have been synthesized. The pyrons have not themselves been prepared because pyrons have not themselves been prepared because 4H pyron has recently been synthesized from glutaric dialdehyde, but their simple derivatives of pyran we synthesize here with the help of alpha dash dioxopimelic acid. I write down structure for preparation of derivative of pyran. CH2 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 CO CO COOH COOH. This is alpha dash dioxopimelic acid. Undergone treatment with sulfuric acid, removal of 1 water molecules gives derivative as 2,6-dicarboxy 4-pyran. Dicarboxy 4-pyran with the help of alpha dash dioxopimelic acid undergone treatment with sulfuric acid and removal of 1 water molecules give 2,6-dicarboxy 4-pyran. Now we see some properties. 4-pyran is a colorless liquid. So liquid, its boiling point is 48 degrees Celsius. Colorless, but which turns brown in air, in open air. It turns brown. On hydrogenation, it gives tetrahydropyran. Tetrahydropyran. On hydrolysis, pyran gives tetrahydropyran. For pyran, it is interesting to note that 4-hydrogen pyran is not aromatic. We write down structure, tautomeric structure of pyran. So 4-hydropyran is not aromatic. It is due to the fact that although pyran has 6 electrons, 4 from 2 pi bonds and 2 from oxygen atoms. So pyran has 6 electrons, and these 6 electrons, C4 is sp3 hybridized and has no para orbital available for cyclic para orbital overlap. However, if C4 is converted to a carbonium ion, it will become sp2 hybridized. sp3 is converted into sp3 and now would have an empty para orbital for cyclic overlap. So it is not aromatic. So it is very interesting and important point for pyran. Is not aromatic. Is not aromatic. Now we see second depression for derivative of pyran. Dihydropyran can be obtained by heating tetrahydrofuryl alcohol over alumina at 300 degrees Celsius. Second one is this is tetrahydrofuryl. With the help of reduction takes place, so CHO is converted into CH2OH, tetrahydrofuryl alcohol, and it is treated with alumina Al2O3 at 300 degrees Celsius. Loss of 1 water molecules convert into dihydropyran. So this is second derivative of pyron. Dihydropyran can be obtained by heating tetrahydrofuryl alcohol over alumina at 300 degrees Celsius temperature. This this compound, dihydropyran, is used as protecting agent for alcohol and phenols because the compound condenses with alcohol or phenols in presence of anhydrous acid to give an acetal form, which alcohol can be easily regenerated by mineral acids. So we have one derivative, this dihydropyran, Now we see more and above from dihydropyran to tetrahydropyran. So we discuss dihydropyran. I write down structure of dihydropyran. I write down structure of dihydropyran in middle. So we discuss more reactions with small space. This is dihydropyran. It is further noted that pyrans have not themselves been prepared, but their simple derivatives have been synthesized. So we convert from dihydropyran, pyrans to dihydropyran, and this pyran, dihydropyran, is used as protecting agent for alcohol and phenols, because the compound condenses with alcohol or phenols in presence of anhydrous acid to give an acetyl form, which alcohol can be easily regenerated by mineral acid. Mineral acid. So we write down this very important application as reaction. If we treated this dihydropyran with alcohol or phenols, so it is converted, these alcohol phenols are presence of anhydrous acid to give acetyl derivative. And further it convert into alcohol is regenerated easily by mineral acid. On catalytic reduction with the help of this dihydropyran, if we use catalytic reduction with the help of Raney nickel, dihydropyran gives tetrahydropyran. So catalytic reduction takes place with the help of Raney nickel. Then it converts into tetrahydropyran. This is tetrahydropyran. Tetrahydropyran. So on catalytic reduction of dihydropyran give tetrahydropyran, and it is used as a solvent. The sugar in their 6-member cyclic form pyranose may be considered as the derivative of tetrahydropyran. Tetrahydropyran on oxidation with nitric acid gives glutaric acid. On nitration, this tetrahydropyran on nitration with the help of nitric acid and sulfuric acid, then it convert into CH2 thrice COOH. It is known as glutaric acid. So, nitration of tetrahydropyran gives glutaric acid. Carbon monoxide and steam in presence of catalyst convert tetrahydropyran into pimelic acid. Tetrahydropyran into pimelic acid with the help of carbon monoxide CO and water steam. Carbon monoxide and steam in presence of catalyst. Tetrahydropyran is converted into CH2 5 times COOH, and this is pimelic acid. So, with the help of carbon monoxide and steam, it converted into pimelic acid. Now, we have one more. With the help of hydrobromic acid in presence of sulfuric acid. Hydrobromic acid in presence of sulfuric acid. Hydrobromic acid, that means HBr, in presence of sulfuric acid, then we get 1,5-dibromopentane. 1,5-dibromopentane, and this is BrCH2 thrice CH2Br, 1,5-dibromopentane. So these are very important. These are very important compounds we get from derivatives of pyran. Derivatives of pyran. So these are very important information of 6-member ring containing one heteroatom as oxygen, that is pyran. Now we see our next compound. For next compound, we see 6-member ring heterocyclic compound. First we see in 6-member nitrogen as heteroatom, so that is pyridine. And previous this, if oxygen, then it is pyran. Now we see the 6-member ring containing 2 heteroatoms. Very important compound. 6-member ring heterocyclic containing 2 or more heteroatoms. 6-member ring. Containing 2 or more heteroatom, and all are known as azenes. All are known as azenes and also known as diazenes. If we have 2 nitrogen as heteroatom, 2 heteroatom nitrogen, then it is known as diazenes or azenes. So 6-member ring containing 2 nitrogen as heteroatom in their ring structure, they are known as diazines or azines. And according to our syllabus, we have three azines or diazines, and these three are pyridiazine, number one. Number two is pyrimidine, and number three is pyrazine. These three azines or diazines are six-member ring containing two nitrogen as heteroatoms. There are three types of isomeric diazines are well known, and these three are pyridiazine, pyrimidine, and pyrazine. Now we see the structure one by one. Six-member ring containing two heteroatom as nitrogen. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we also write down this orthodiazine, metadiazine, and paradiazine. All these three derivatives are in our syllabus. So let us we see one by one in detail. First of all, we see pyridiazine. Pyridiazine or orthodiazine. Orthodiazine. We write down structure in above discussion. So we start with preparation. We see preparation. Pyridiazine may be synthesized by reaction of maleic dialdehyde, CH double bond CHO, that is CHCHO, and that is CH double bond O, that is maleic dialdehyde. Treated with hydrazine NH2. So loss of two water molecules, it converts into pyridiazine. pyridiazine. With the help of maleic dialdehyde and hydrazine gives pyridiazine. Second, with the help of unsaturated unsaturated 1,4-dicarbonyl compound, unsaturated 1,4-dicarbonyl compound, structure of 1,4-dicarbonyl compound, that is unsaturated 1,4-dicarbonyl treated with hydrazine gives derivative of we write down his dash. So derivative of pyridiazine. Pyridiazine 3,6 dialkyl pyridiazine. So with the help of pyridiazine, with the help of 1,4-dicarbonyl compound and hydrazine gives pyridiazine, derivative of pyridiazine. And this derivative pyridiazine undergone by, if the alkyl group, we have here CH3, then this is dicarbonyl compound, our ketonic group contains here CH3. So first of all we see oxidation and then decarboxylation. So CH3 is converted into COOH and COOH is removed. We get pyridiazine. So these are very important synthesis of pyridiazine. Now we see properties of pyridiazine. Pyridiazine is in the form of liquid and it contains nitrogen, so it is weak base. And in liquid form. It is weak base. Liquid. So its boiling point is 210 degree Celsius. Exhibit aromatic characteristic. Electrophilic substitution reaction in pyridiazine is very difficult, but after conversion of pyridiazine to pyridiazine 1 oxide by perbenzoic acid, the electrophilic substitution reaction proceed in a easy method and various substitution products are obtained. It is noted that electrophilic substitution reaction in pyridine is very difficult, but after converting pyridiazine to pyridiazine 1 oxide by perbenzoic acid, the electrophilic substitution reaction proceed in a easy method and various substituted products are obtained. So we will discuss their chemical properties. Pyridiazine. I write down structure here in center. This is pyridiazine. First of all, we see reduction. First of all, we see nitration. Here, directly nitration is not possible. We discussed about this electrophilic substitution. So, in center we have not used pyridiazine. So, I rub out and I write down pyridiazine inside. With the help of perbenzoic acid, we discuss pyridiazine is converted into pyridiazine 1 oxide. So, perbenzoic acid C6H5OCOOH. This is perbenzoic acid. Removal of benzoic acid, it is converted into pyridiazine 1 oxide. And now this pyridiazine 1 oxide is proceed in a easy method and various substitution takes place. So if we treated this as nitrating mixture, nitration takes place. So we get 4-nitropyridine 1 oxide. 4-nitropyridine 1 oxide. 4-nitropyridine 1 oxide. This is 4-nitropyridine, pyridiazine 1 oxide. Pyridiazine 1 oxide. For nitropyridiazine 1 oxide is formed. And if we treated this 4-nitropyridiazine is undergone by reduction, then nitro is converted into amino. And we get 4-aminopyridiazine. 4-aminopyridiazine. And if we take place halogenation, halo compound, chlorine, bromine, iodine, so we get 4-halopyridiazine. for halopyridazine. So, electrophilic substitution reaction in pyridazine is very difficult, but after converting pyridazine to pyridazine 1 oxide by perbenzoic acid C6H5O COOH, this is perbenzoic acid. The electrophilic substitution reaction proceed in a easy method. And various compounds nitropyridazine, aminopyridazine and halo 4-chloro, 4-bromo, 4-iodopyridazine we obtain. So these are very important chemical properties of pyridazine. Today we stop here over this lecture. Okay, thank you.